Welcome back to the second part. I want to show you two more examples on how to do the definite integration to find the area with different horizontal, vertical slicing and different partitioning. So now look at this. This is the same question, right? Left and right, but on the left hand side, I try to do it with horizontal slicing. On the left hand side, I try to do it with vertical slicing. But whether you are doing it horizontally or vertically, the first important thing is to find out these intersection points, right? Because these are the boundaries if you do it left and right, up or down. All right, so you can solve between these two equations. Y squared is x, y squared is y and 2. So one way or another, you got this intersection point. This is 0 0, this is 1 and minus 1, and the top point will be 4 and 2. All right, this is 4 and 2, this is 1 and minus 1, this is 0. All right. Okay, so let's look at the left hand side. Horizontal slicing. Now it's easier because you don't have to do the partition. Always, each of this rectangle is always the blue on the right and the red on the left. So it's always the blue x minus the red x. Alright? And we integrate with respect to y, dy. We do it with the smallest y, that is y being minus 1, all the way to the largest y. The y will be 2. Alright, so the boundary will be from minus 1 and 2. This is the area. From y is minus 1 to y is 2. Alright. So we put back the blue x and the red x, and that goes to from minus 1 to 2 is y plus 2. Subtract from it y squared. Alright. And integrate dy. So that goes to y squared over 2 plus 2y minus 1/3 y cubed from minus 1 to 2. So that would be 2 plus 4 minus 8 over 3. That is when y is 2. Subtract from it when y is minus 1. That is 1 over 2 minus 2 plus 1/3. Alright. If you add all them up together, that goes to 9 over 2. Alright. That is the area according to the horizontal slicing. Now at the same time, we can do it with a vertical slicing. But when you do it with vertical, notice you have to split into part A and part B because they have different formula. If you look at the area in part A, they are the red above the green. Now I have to split the curve into red and green because for every x, for every y, there are two possible, for every x there are two possible values of y. It can be plus square root x on above the x-axis or minus square root x below the x-axis. So this part should be in red. It follows the equation y is plus square root x. This part is in green. It follows another equation y is the negative of square root x. Alright. So in region A, it is the red above the green. Alright. In region B, it is the red above the blue, so they follow different equations. In A, we have the red y, subtract the green y, alright? And then we do a integrate with respect to x. And that should be the boundary for x. It is x equals to 0 all the way to 1, x from 0 to 1 for region A. And that goes to 0, 1, and twice root x, alright, dx, and that goes to 4/3, alright, x 3 over 2 from 0 to 1, and the answer goes to 4/3. Right, that is only for A. That is only for A. We also have to do it for B, alright. For B, that would be the red y, subtract, now this time we subtract the blue for part B, alright, subtract the blue y, and then we do the dx. The boundary will be from 1 to 4. That is the boundary for x, right? Because this x equals to 4. Alright? X equals to 4. So that is from 1 to 4. Alright? And that goes to root x minus the y will be x minus 2. Alright? Dx integrate from 1 to 4. And that is 2/3 x 3 over 2 minus half x squared plus 2x, alright? That is from 1 to 4. So finally, we add up the two answers together. This is 19 over 6, I suppose. and then we add them up together. The final answer, a plus b, it is the same 9/2. Alright, so in this question I try to demonstrate how to approach the same area with vertical or horizontal slicing. Sometimes, like the left hand side, you don't need to do any splitting, but on the right hand side you have to split into region, because a and b, they have different integration. The formula, they are not the same, because when you do the vertical slicing, the curves that you touch, it may not be consistent all the time. Most importantly, notice the change in the boundary, whether you want to do it horizontal, vertical, with or without partitioning. Alright, so that is example number 1. Moving on, we have example number 2. Once again, there are 3 curves. Alright, I want to do it with 2 different ways. Alright, on the left hand side, I want to do it with a vertical slicing A and B, whereas on the right hand side, I want to do it with a mixture of horizontal and vertical slicing. That is on the right hand side. Alright, part C and D. And let's see whether to add up to the same answer. Alright, so in part A, alright, most importantly, before we start, we need to find the intersection points, right? This tells us what are the integration boundary. So we solve the red and the green, you got this intersection point, right? To save time, let me just give you the point, right? Of course, in an examination, sometimes you have to find out these points on your own. Alright, this is 1, 3 here, it's 2, 0, and this is origin here. Alright, so now let's do it one by one, right? In part A, we have the red y, that is 3x, subtract the green will be x squared minus 2x, alright? And then we do the dx, that is the boundary for x will be from 0 to 1 to 2, alright? X will be like this. So the boundary is from 0 to 1. So it goes to 5x squared over 2, subtract x cubed over 3, that is from 0 to 1. And the portion A, the area is 13 divided by 6. Alright. By similar token, the B will be like this. But in B, that would be the blue. Alright, 6 minus 3x, subtract the green, x squared minus 2x. Notice in region B, the blue is always over the green, so it should be the blue subtract the green. And the boundary should be from 1 to 2, right? In B, the boundary is from 1 to 2. Don't forget the dx. Alright. So this one eventually goes to minus 1/3 x cubed plus 1/2 x squared plus 6x. Alright. I might have skipped some steps in the simplification, right? So feel free to pause the video and try to work it out on your own to see how do we arrive at this line to this line, okay? And of course, you have to put back the 1s and 2s into this, and it is also the 13 over 6. So altogether, the total area will be the sum of these 2, and the area will be 13 over 3, alright? Now, that's how we did it on the left-hand side. Let's see whether we will arrive at the same answer on the right-hand side, okay? On the right-hand side, we have C and D, right? C, I want to do with a horizontal slicing. So part C will be, the blue x subtract the red x, alright? And then integrate with respect to y. The boundary for y will be, that is the y is 0 all the way from y equals to 3, alright? We do the integration from 1 to 3 here. From 0 to 3, alright? And you notice I also changed some of these straight line. Y is 3x on the left hand side, but I changed it to x is y over 3 on the other side, right? It's a change of subject, so that I can do this integration easier, right? That would be 6 minus y over 3, subtract from it y over 3, and then dy, alright? That would be 2y minus 1/3 y squared from 0 to 3, alright? And this goes to 3. That is only for C part, alright? Now, for part D, it's not easy to do it with horizontal slicing, so I keep using vertical slicing for D, alright? For D, the x will be 0 all the way to x equals to 2. Alright, so part D goes like this. It's from 0 to 2. We have the purple line minus the green line. The purple line is x being 0, and you subtract the green line. The green line is x squared minus 2x. Alright, that is the green line. So we have dx finally. Alright, so the green one will the d part will be x squared minus x cubed over 3. Alright, from 0 to 2, and that answer goes to 4/3. Alright, once again you have to put back the numbers 0 and 2 to find the answer, and these two add up together. Alright, obviously it's the same 13/3. So I have shown you yet another example to show you how to do it with vertical, horizontal, and different methods of slicing. Alright, and in part 3 we'll look at some past paper questions.